This LOS is explain how the value of an option is determined using a one-period binomial model. Pricing and valuation of options. Now we're going to look at the binomial valuation of options. And recall the LOS says explain, okay? It says explain how the value of an option is determined using a one-period binomial model. But we're going to go through the calculations. You need the calculations for level 2 because in CFA level 2 you have to calculate the value of an option using the binomial model. And in fact, you have to do it using a two-period binomial model. Anyhow, with put-call parity, we found that we could price a put or a call based on the prices of the combinations of instruments that make up the synthetic version of the instrument. If we wanted to determine a call price, we have to have a put. If we wanted to determine a put price, we had to have a call. What we need to be able to do is price a put or a call without the other instrument. In this section, we introduce a simple means of pricing an option. It may appear that we oversimplify the situation, but we shall remove the simplifying assumptions gradually and eventually reach a more realistic scenario. The approach we take here is called the binomial model. The word binomial refers to the fact that there are only two outcomes. In other words, we let the underlying price move to only one of two possible new prices. As noted, this framework oversimplifies things, but the model can eventually be extended to encompass all possible prices. In addition, we refer to the structure of this model as discrete time, which means that time moves in discrete increments. Okay, we're going to walk through this fairly slowly. So we're looking at the pricing and valuation of options, and now we're looking at the one-period binomial model. So we're going to start with a call option. Remember, that gives us the right but not the obligation to buy stock, for example. If the underlying goes up to S plus, the option would be worth C plus. So remember, with a call, the value of the option is going to be the maximum of 0 or the underlying price at expiration minus the exercise price. So again, if the exercise price was 100 and the underlying at expiration was 105, buy low, sell high. You have the right to buy at 100. So the value is 105 minus 100 equals 5. Okay, so just a quick little review. You should know that by now. And if the underlying goes down to S minus, the option would be worth C minus. Okay, so we know that if the option is expiring, its value will be the intrinsic value. So again, the maximum of the underlying price at expiration minus the exercise price. So what we need to figure out with this one-period binomial model is that there's two outcomes. The price could go up or the price could go down. We would know the value of the option under those two scenarios, but what would be the value of the call option here? And that's what we're going to calculate. So now we're going to walk through this example. Suppose the underlying is a non-dividend paying stock currently valued at $50. It can either go up by 25% or it can go down by 20%. Okay, so that's how we're going to get our binomial, one-period binomial tree. Okay, so we have an up factor of 1.25 and a down factor of 0.8. So 1 plus 0.25 for the up factor equals 1.25. 1 minus 0.2 for the down factor equals 0.8. Okay, so therefore we can get our stock price, our S plus and our S minus. The stock price when it goes up is going to be 50 times 1.25. So that gives us 62.50. The stock price on the down factor is 50 times 0.8, which is going to be $40. Okay, so assume that the call option has an exercise price of 50 and the risk-free rate is 7%. Thus, the option values one period later would be for the call, it's the maximum of 0, or the underlying price at expiration minus the exercise price. We said the exercise price here is 50, and on the up, it's 62.50. Okay, so we can see 62.50 minus 50 is 12.50. So that's the value of the call right here on the tree after the 1 period, on the up price. So again, 50 times 1.25, 62.50. The value of the call is the maximum of 0. Underlying price at expiration minus the exercise price, 62.50 minus 50. So we have 12.50 here on the upside. That's the value of the call, the intrinsic value. Now on the downside, we can see that the underlying price at expiration is below the exercise price. So why, if I have the right but not the obligation to buy at 50, why would I buy it at 50 when the market price is 40? Okay, so we can see we're going to let the option expire, and the value is 0 because the maximum is 0, or in this case 40 minus 50, that's a negative. Okay, so the next stage, so what we've done now is, just as a quick review before we go to the next slide, we're given a non-dividend paying stock, currently valued at 50. We're given the up factor and down factor, and then we're given the exercise price of the call, and so therefore we can calculate the intrinsic value of the option, the intrinsic value of the option value for the up and for the down, okay? So on this slide, we're going to go through the calculations, how we calculate the call value here at time 0, okay? So this is just a quick review from the previous slide. Recall that the stock price is 50 and the exercise price of the option is also 50. And the up factor, the stock could go up by 25% or it could go down by 20%. Okay, so we had an up factor of 1.25 and we had a down factor of 0.8. Okay, that was the U and that was the D. All right, so therefore, starting at $50, if it went up by 25%, we'd be at $62.50. The value of the call option is the maximum of 0, or the price of the underlying at expiration minus the exercise price. The exercise price was 50. So 62.50 minus 50, we have the value of the call option at period 1 at expiration being at 12.50. Now on the downside, the stock could go down by 20%, so 50, the down factor is 0.8. 50 times 0.8 equals 40. So we know the call option is going to expire worthless. The value is going to be 0 because buy low, sell high. I have the right but not the obligation to buy at 50. Why would I buy at 50 when the underlying is priced at 40? So again, the maximum is 0, or the underlying price at expiration minus the exercise price. 40 minus 50 is negative 10. I'm not going to do it. It's going to expire worthless, okay? So now we're going to move into the calculations. And again, the LOS does not say calculate, it says to explain. But if you understand if you memorize the formula, if you know how to calculate it, then surely you can explain it. And for CFA level 2, you have to be able to calculate it, so you have to memorize these formulas, okay? So step number 1, the first thing that we need to calculate is this little algebraic symbol for pi. And this is the risk-neutral probability is what they call it, okay? And that formula is not too difficult. In the numerator, we've got 1 plus R minus D. Now recall from the previous slide, R is the risk-free rate, and it equaled 7%, okay? That was given to us. So 1 plus 0.07 minus the down factor, 1.07 minus 0.8 is in the numerator. And for the denominator, it's just the up minus the down factor. So 1.07 minus 0.8 divided by 1.25 minus 0.8, we get this risk-neutral probability to be 0.6. Okay, that's step 1. Step 2 now, here's where we have the formula to calculate the price of the call here at time 0. Okay, so in the numerator, we've got this risk-neutral probability times the call price if the stock goes up, C plus, which we know is 12.50. So therefore, this would be 0.6 times 12.50, okay? And then it's plus 1 minus the risk-neutral probability, so that's going to be 0.4, 1 minus 0.6, times the call value if the stock price goes down, which is 0. So we can see this part of the equation is going to be 0 anyhow. So in our numerator, we're going to have 0.6 times 12.50. And in our denominator, we've got 1 plus R, which is the, as we said, the risk-free rate, okay? So here we have the calculation for the price of the call. The numerator is 0.6 times 12.50 divided by 1.07, and we get 7.01. So therefore the option should sell for $7.01, okay? Again, the LOS is not to calculate, it's to explain, and but we're working through the calculations here. Step 1, you need to calculate the risk neutral probability. Step 2, you have to use the formula to calculate the price of the call, okay? So the expected payoff is based on risk neutral probabilities. The expected payoff based on risk neutral probabilities is discounted at the risk-free rate. That's what's happening here, okay? So here's a little practice question. Note the LOS says explain, but you need to do this in level 2. So this is just running through another example of exactly what we already did, okay? And the goal is to determine the price of a European call option with an exercise price of 70, okay? So let's go through the information that they're given. In this case is that consider a one-period binomial model in which the underlying is at 65. So the stock price right now is at 65. And it can go up by 30% or it can go down by 22%. The risk-free rate in this case is 8%. So therefore the up factor is 1.3, 1 plus 0.3, and the down factor is 0.78, 1 minus 0.22, okay? So we're going to determine the price of European call option with an exercise price of 70. So the first thing that we do is we look, we're starting at $65. If the stock could go up by 30%, it's going to be 65 times 1.3. The stock price on the upside would be 84.50. So then we can value the value of the call at C plus is the maximum of 0 or the price of the underlying at expiration minus the exercise price. And we have an exercise price of 70. So 84.50 minus 70, the value of the call option here after one period is 14.50. Now on the downside, our down factor is 0.78, 1 minus 0.22. So 65 times 0.78 is going to give us $50.70, okay? Now the exercise price is 70. So the value of the call option at C minus is the maximum of 0 or the price of the underlying at expiration minus the exercise price. So we know that's going to be negative, so we're not going to exercise the option. The value is going to, of the option is 0, okay? Buy low, sell high. Why would I have the right but not the obligation to buy at 70? Why would I do that when I could buy it for $50.70 in the market, okay? So the next thing that we're going to do to value the call option here at time 0 is recall the first thing that we're going to do is we're going to calculate the risk neutral probability. And here's the formula for the risk neutral probability. You don't need to memorize it for level 1, but you do for level 2. The numerator, 1 plus the risk-free rate, so 1 plus 0.08, because we've got the risk-free rate here, 8%, minus the down factor, 0.78. That's in the numerator. And the denominator is just the up minus the down, 1.3 minus 0.78. So we calculate the risk neutral probability to be 0.5769, okay? So the next thing that we're going to do is we're going to calculate the value of the call. And here's the formula in the algebra. The numerator is the risk neutral probability times C plus, the value of the call option at if the stock price goes up. We know that was 14.50. So we can see that here in the numerator, 0.5769, the risk neutral probability times 14.50, okay? Then it's plus 1 minus the risk neutral probability times C minus, but we know C minus is 0. So this part of the equation is going to scratch out to be 0. So and we're going to divide by 1 plus the risk-free rate. So our numerator, 0.5769 times 14.50 divided by 1.08, we get the value of the call option here to be $7.7454, okay? So that's a nice little review of how we calculate the, we did the calculations, the LOSs explain, and we calculated the price of the call using a one-period binomial model. So now we're just going to go through a quick example how we calculate the price of a put, because recall the LOSs explain how the value of an option is determined using a one-period binomial model. It doesn't say explain how the value of a call option is determined, so it could be a put as well, okay? So here we have the formula, how we calculate the value of a put, and in the numerator we've got the risk neutral probability times the value of the put if the stock price goes up, plus 1 minus the risk neutral probability times the value of the put if the stock price goes down. divided by 1 plus the risk-free rate, okay? So the risk-neutral probability is determined by the same formula for puts or calls, and it's down here. We calculate the risk-neutral probability. So remember, the numerator is 1 plus the risk-free rate minus the down divided by up minus down. So we get a risk-neutral probability of 0.667, okay? So now we're going to look at a simple example where the price at time zero, the stock price at time zero is 40 pounds. The risk-free rate is 5%, and the up factor is 1.2, and the down factor is 0.75. So that means the stock can go up by 20% or it can go down by 25%. So the up is 1.2 and the down is 0.75, okay? So therefore, if we look at the S plus at period 1, it's going to be 40 times 1.2, we're at 48 pounds. And the price of the stock, if it's S minus, is going to be 40 times 0.75, which is 30 pounds. So now we're going to look at the call and a put. They both have an exercise price of 38, okay? So now we're going to look at the values of the call and put at the end of the time period one period binomial model. So let's start with the calls first. We should be familiar with that. So the exercise price is 38. If the stock price goes up, it's at 48. So I've got the right, but not the obligation to buy at 38, buy low, sell high. I'm going to do it. The price, the value of the call, the intrinsic value of the call, if the stock price goes up, is the price at expiration, 48 pounds, minus the exercise price, positive value of 10 pounds. If the stock price goes down to 30 pounds, I have the right but not the obligation to buy at 38. Why would I exercise my option if I could buy at 30? So it's going to value, the value of the option is going to be 0, okay? It's going to expire worthless. Now, so that's a review, okay? So we might as well just finish up with the call because that's previously what we did. We can then calculate the value of the call option. In the numerator, we have the risk-neutral probability times the value C plus 1 minus the risk-neutral probability times C minus. And we know C minus is going to be 0. So this part of the equation strikes out to be 0. So the numerator is just going to be the 0.667 times 10 pounds divided by 1 plus the risk-free rate. And we get the value of the call option to be 6 pounds and 35 cents, okay? So let's move on to the put. This is a little bit new. So again, I have the right but not the obligation to sell at 38. So if the stock price goes up to 48, why would I sell at 38 if I could sell at 48, right? So therefore, we know that the value of the put is the maximum of 0 or the exercise price minus the price at expiration. So 38 minus 48 is negative. So if the stock price goes up, the value of the put is 0. But if the stock price goes down to 30, I've got the right but not the obligation to sell at 38, sell high, buy low. I'm going to, the value of the option therefore is maximum 0. Or again, you can see exercise price minus the price at expiration, 38 minus 30. I have a positive value on the P minus of 8 pounds, okay? So then we can plug that into the formula for how we calculate a put. It's going to be the risk-neutral probability times the value of the put if the stock price goes up, which was 0, plus 1 minus the risk-neutral probability times the value of the put if the stock price goes down, divided by 1.05, 1 plus the risk-free rate. If we do the math there, so we can see this part is going to strike out to be 0. And so we're going to have 1 minus 0.667 times 8 pounds divided by 1.05. We get the value of the put to be 2 pounds 54, okay? So the value of European options can be obtained using the binomial model, which specifies 2 possible prices of the asset 1 period later, and that enables the construction of a risk-free hedge consisting of the option and the underlying, okay? So again, this LOS, you don't need to do the calculation, but you need to explain it. And in level 2, you do need to do the calculation. So it's, you know, the more that you can memorize and understand and work your way through, obviously the stronger you're going to be. So now we're just going to work through a series of practice questions to finish the LOS, and you're going to see there's no calculations because the LOS has explained how the value of an option is determined, okay? So the first practice question here, which of the following terms directly represents the volatility of the underlying in the binomial model? A, the standard deviation of the underlying, B, the difference between the up and down factors, or C, the ratio of the underlying value to the exercise price? The correct answer is B. The up and down factors express how high and how low the underlying can go. Standard deviation does not appear directly in the binomial model, although is implicit. The ratio of the underlying value to the exercise price expresses the moneyness of an option. Okay, so the correct answer is B. Which of the following terms directly represents the volatility of the underlying? It's the difference between the up and down factors. Next practice question. Which of the following is not a factor in pricing a call option in the binomial model? A, the risk-free rate, B, the exercise price, or C, the probability that the underlying will go up? Okay, this one I highlighted there in red because we're looking for which is not a factor. Sometimes those can trip you up, okay? So again, in pricing a call option in the binomial model. So again, you don't need to do the calculation, but you pretty much have to be familiar and memorize the formula so that you know what is a factor in the model, okay? So I put there the call, how you calculate the price of the call is the risk neutral probability times the value of the call option if the stock price goes up, plus 1 minus the risk neutral probability value of the call option if the stock goes down, divided by 1 plus the risk-free rate, okay? And remember, the C plus is the maximum of 0, the price of the underlying minus the exercise price, okay? So you can see the risk-free rate is in the formula, that's in the denominator, 1 plus R, and the exercise price is highly relevant because that's how we calculate the C plus and the C minus, okay? So which one is not a factor? Well, it's C, the probability that the underlying will go up, okay? Good little question. So 2 more practice questions to finish this LOS. The first one, which of the following best describes the binomial option pricing formula? A, the expected payoff is discounted at the risk-free rate plus a risk premium. B, the spot price is compounded at the risk-free rate minus the volatility premium. Or C, the expected payoff based on risk-neutral probabilities is discounted at the risk-free rate. Again, as I said, this LOS you don't need to calculate, but you pretty much have to memorize the formula because this question, which of the following best describes the binomial option pricing formula, is putting the algebra into words, and the correct answer is C. The expected payoff based on risk-neutral probabilities is discounted or divided by 1 plus the risk-free rate, okay? So C is correct, risk-neutral probabilities are used, and discounting is at the risk-free rate. There is no risk premium incorporated into option pricing because of the use of the arbitrage. So again, there's the formula to calculate the price of a call, the numerator, risk-neutral probability times the value of the call if the stock price goes up, plus 1 minus the risk-neutral probability times the value of the call if the price the stock goes down, okay? So we're calling that the expected payoff based on risk-neutral probabilities, okay? And you're discounting it by the risk-free rate, 1 plus R, divided by 1 plus R. And one last practice question just to finish this LOS. Which of the following is least likely to be required by the binomial option pricing model? A, spot price, B, 2 possible prices 1 period later, or C, actual probabilities of the up and down moves? I think that's a fairly easy one. We know we start with the spot price because we need to know then we multiply the spot price times the up factor and the down factor. And we need the 2 possible prices 1 period later. That's the whole point of the binomial model. So C is correct because we're looking for the least likely. We're looking for the false. And the actual probabilities of the up and down moves in the underlying do not appear in the binomial option pricing model, only the pseudo or risk neutral probabilities. Both the spot price of the underlying and 2 possible prices 1 period later are required by the binomial option pricing model. Okay, so that's, I think, a fairly easy question to end on. And with that, that's the last slide for this LOS. Thank you.